Dear students, this is Prof.Romana. Today I am going to discuss linear motion. Linear motion means motion of a body along a straight line. It is also called one-dimensional motion. In linear motion, first of all, what do you mean by rest and motion? A body is said to be at rest if it doesn't change its position with respect to the surroundings. Whereas a body is said to be in motion if it changes its position with respect to the surroundings with the passage of time. But rest and motion are all relative. Means no body is at permanent rest and no body is in permanent motion. For example, when we are traveling in a train and we are sitting on our respective seats inside the train, so we all are at rest with respect to one another. But for an observer standing on the ground, we all are in motion and moving with the velocity of the train. So one body may be at rest with respect to one observer and may be in motion with respect to another observer. Then we come to distance and displacement. To differentiate between distance and displacement, suppose you move from one place to another place. Then distance covered by the body is equal to the length of the path followed by the body, which may be curved or straight. But distance is equal to the total path length, whereas displacement is only the length of the shortest path, initial to final position. So distance is a scalar quantity, displacement is a vector quantity. Both distance and displacement are measured in centimeter in CGS system and meter in SI system. So displacement may be positive, negative or zero, but distance can never be negative. So displacement is always less than or equal to distance. So this is the relation between displacement and distance. For example, when you go from your home to your school and come back from school to home, suppose distance between your school and home is 5 kilometers. The total distance covered by you in this journey will be 10 kilometers, whereas displacement covered by you will be only 0. So displacement will be 0, positive or negative. Then we come to speed and velocity. Now speed is known as rate of change of distance covered by the body, whereas velocity is defined as rate of change of displacement covered by the body. Speed is a scalar quantity, velocity is a vector quantity. Both speed and velocity are measured in centimeter per second in CGS system, meter per second in SI system. Whereas speed and velocity, when they vary, then we find average speed. So average speed is defined as total distance over total time. Whereas average velocity is defined as net displacement over time taken, total time taken. Then we come to acceleration. Now acceleration is defined as the rate of change of velocity. When velocity increases or decreases, body is said to be accelerated. So acceleration is defined as the change in velocity v minus u upon t, where u is the initial velocity of the body, v is the final velocity of the body, or this implies V minus U is equal to AT, or this implies V is equal to U plus AT. This is the fundamental equation of motion, where U is the initial velocity, V is the final velocity, T is the time, and A is the uniform acceleration. So this acceleration is measured in meter per second square in SI system and centimeters per second square in CGS system. So acceleration is also a vector quantity. It may be positive or negative. Now we come to types of motion. Motion is of two types. One is uniform motion. Now uniform motion. What is uniform motion? When velocity of body is uniform, that is constant, then motion of the body is said to be uniform motion. And if we plot a graph, distance versus time graph for uniform motion, taking time along x-axis and the corresponding values of distance covered along y-axis, we get a straight line OA. And if we draw perpendicular AC on x-axis, so this is the position time graph or distance time graph for uniform motion, which is body is moving with the uniform velocity. Now what is the importance of this graph? If we find slope of this graph, slope is always given by, in a right angle triangle, perpendicular or base, that is AD over OD, which is S is the distance covered after time t, and S upon t. So S upon t is nothing but speed or velocity, because when motion is uniform, speed and velocity are equal. So knowing position time graph, distance time graph, and knowing slope of distance time graph, we can find uniform velocity of the body. Second, if we plot velocity time graph, taking time along x-axis and velocity of the body along y-axis, so we get a straight line parallel to time axis, and this means velocity is always constant with the passage of time. And what is the importance of this velocity time graph? So if we calculate area under this straight line AD, then it comes out to be area under AD, length into breadth, that is V into T. What is VT? V into T is distance covered. So knowing area under velocity time graph, we can find distance covered by the body. Knowing slope of position time graph, we can find velocity of the body. So this is uniform motion. Now we come to non-uniform motion. Non-uniform motion, it is of two types. Number one, uniformly accelerated, and number two, non-uniformly accelerated. Uniformly accelerated motion means when acceleration of the body is uniform, that is its velocity is increasing or decreasing at constant rate, then motion is said to be uniformly accelerated. And if velocity of the body is increasing or decreasing at non-uniform rate, then its motion is said to be non-uniformly accelerated motion. But we will discuss only uniformly accelerated motion. Suppose A is a uniform acceleration with which body is moving along a straight line, and then if we plot position time graph for a body moving with uniform acceleration, and suppose body is speeding up, body speeds up, then graph comes out to be a parabola like this. When body speeds up, means its velocity is increasing, and when its speed is slowing, speed is decreasing, we get a graph like this. This is when speeds down. So position time graph or distance time graph for a body moving with uniform acceleration comes out to be a parabola. And again, if we have to find velocity of the body from this graph at any time, then take a point and draw a tangent and find its slope. So slope of the tangent to the parabola at any time will give you velocity of the body at that time, because velocity is changing. So again, knowing distance time graph, we can find velocity of the body at any instant. Then we come to velocity time graph for a body moving with uniform acceleration. So it comes out to be a straight line like this, AB. Now from B, draw perpendicular BD on x-axis and BC perpendicular on x-axis, BD perpendicular on BC. Then let V is equal to final velocity after time t, V. U is equal to initial velocity and T is equal to time, after which we have to calculate final velocity V. So from this graph we can derive all the three equations of motion, which are very important. So to derive three equations of motion, first of all, suppose we have to derive V is equal to U plus AT. To derive V is equal to U plus AT, from this graph, just take right angle triangle ABD. Find its slope. Why slope? Because slope of velocity time graph is numerically equal to acceleration. We have proved. So therefore, A is equal to slope of AB, straight line AB. Slope of AB is equal to acceleration. So slope is BD upon AD. BD upon AD. What is BD? So BC is B, this is U, this is also U, opposite side of rectangle, and this will be B minus. So it will be V minus U upon AD is T. So this implies V minus U is equal to AT, or this implies V is equal to U plus V is equal to U plus AT. So first equation of motion, very simple. To derive second equation of motion, that is S is equal to UT plus half AT square. Now we have already proved that area under velocity time graph is numerically equal to distance covered. So to find distance covered S, so we can find area under VT graph, that is area under VT graph. It comes out to be area of rectangle plus area of triangle. Simple. Area of rectangle is length into breadth, so it is U into T plus area of triangle. Formula is half base into height. So half base is T into height is V minus U. So this implies S is equal to UT plus half into T. What is V minus U? From this equation, first equation, V minus U is equal to AT. So it is AT. So S is equal to UT plus half AT square. This is second equation of motion. So we can derive all the three equations of motion. Now to find third equation of motion, let us make space. To write third equation of motion, that is V square minus U square is equal to 2AS. Again, we have distance in this equation. So distance covered is equal to area under VT graph. But in this case, we will take area of trapezium. Same diagram, area of trapezium is equal to area of trapezium. So area of trapezium is equal to half, this is the formula, sum of parallel sides. Parallel side means BC plus OA. BC plus OA. into perpendicular distance, that is AD, or S is equal to half BCB is V plus U, AD is T. Because in this equation there is no T, so we have to eliminate T. So from this equation, T is equal to V minus U upon T is equal to V minus U upon A, using first equation. First equation is used in both second and third. So it comes out to be S equal to half A V square minus U square, or this is right, V square minus U square is equal to 2AS. So we have third equation of motion. It means using velocity time graph for a body moving with uniform acceleration, we can find third equation of motion. Thank you. Stay tuned for next video.